All right, let's look at example 1. The first thing I do when I think about graphing a function is I just look at my graph and see if I can think about what it should look like in the very end. So I kind of look at these two spots here. This one tells me, and we'll kind of discover this more when I'm at school, this one tells me that it's either going to open up or down or be wide or narrow. And since this is a positive value, this is going to be facing up. It's going to open up. And since there's a 2, it's going to be more narrow than if there was a 1. Back up on our parent function, we went over 1, up 1, but since there's a 2, this time we're going to go over 1, up 2, because we would be multiplying our y value, our y value by 2. So I know this is going to be narrow, and I know it's going to face upward. The 6 on the end tells me that it's going to have a y-intercept at 6, so I'm going to go ahead and put that point on here. I know it's going to cross at 6. So the first thing I'm going to do is try to find my vertex point, because I know if I can find my vertex point, then I found my axis of symmetry, and I know that this graph is going to look the same on both sides. So to find the x value of the vertex, I'm going to do the opposite of b over 2a. So if I look back at my equation, a is 2, b is negative 8, you have to take the sign with the number, and c is positive 6. So the vertex is going to be the opposite of the b value. And since my b is negative 8, the opposite of negative 8 is positive 8. So I have positive 8 on top. And on the bottom I have 2 times the a value, and the a value is 2. So I have 8 over 4, which is 2. Now notice I said the x value of the vertex. So this means that the very bottom point, or the very highest point, is going to have the x value of 2. So I have to go back and find the y value. So I'm going to go back to this equation, and instead of x, I'm going to put a 2 where the x is, so that I can find y at that point. So I have 4 times 2, which is 8. 8 times 2 is 16, plus 6. 8 minus 16 is negative 8. Negative 8 plus 6 is negative 2. So I found the very highest or the very lowest point of my parabola. And since this one faces up, what I found is the very lowest point at 2, negative 2. Now, I know there's going to be some points over here, and there's going to be some points over here. So when I try more values for x, I want to try something smaller than 2 and something bigger than 2. Oh, whoops. Thank you. 2, negative 2 is right here. So I want to try something on the left of 2, something on the right side of 2. So I'm going to pick 1 for x and go back and put it in the same equation. So I'm going to have 2 times 1 squared minus 8 times 1 plus 6. So 1 squared is 1, 1 times 2 is 2, minus 8 plus 6. So I have negative 6 plus 6, so I get 0. So when x is 1, y is 0. And I'm going to try something on the other side. I'm going to try 3 for x. So I'm going to put 2 times 3 squared minus 8 times 3 plus 6. 3 squared is 9, 9 times 2 is 18, minus 24 plus 6. 18 minus 24 is negative 6 plus 6, which is 0. So I have another point at 3, 0. Look what happened here. This was the axis of symmetry, the vertex point. These should be the same because this is a place of symmetry. So if I draw my parabola, I know I have this. Also, if I went one more over, I should be up at 6. And it looks like that. Let's try this point 0 and see if that really happens. If I would put 0 in for x, 2 times 0 squared minus 8 times 0 plus 6, this would be 0, this would be 0 plus 6. So if I put 0 in for x, I get 6 for y. So you can see how it's the y-intercept. My axis of symmetry is the line that runs through my vertex. And the equation for this line is x equals 2. So the axis of symmetry Yeah, I didn't write it on here, is x equals 2. The vertex is at 2, -2. So we found 1 point on each side. Notice that it's symmetric on each side of this line of symmetry.